Okay, in this video we're going to finish up 2-4, more on slope. And the first thing we'll talk about today is the slope as a rate of change. Slope is defined as the ratio of a change in y to a corresponding change in x. It describes how fast y is changing with respect to x. For a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. Our next example shows how slope can be interpreted as a rate of change in an applied situation. When calculating slope in applied terms, problems, keep track of the units in the numerator and denominator. And it's going to be numerators per denominators. The one thing I really found that sticks with high school aged students, this is something that you can relate to. Our x-axis might be time, and let's say it's in hours. And our y-axis might be in distance or miles. So if we want to look at this as a rate of change, here are 2 points. If we connect them, our change in y is going to be our change in miles. And our change on the x-axis will be change in time or hours. And I said numerators per denominator. Who hasn't heard of miles per hour? That is your rate of change. As you fly down I-80, you got your foot on the gas pedal. How is your position changing in relation to time? Well, you can count it as miles per hour. Y-axis per x-axis. So example 3. The line graphs for the number of women and men living alone are shown in the figure. Find the slope of the line segment for the women. Describe what the slope represents. Okay, what we're doing here, we're going to do the line for the females, the upper line, looks like burgundy. When you do the huddle problems, the practice problems, you're going to do the same song and dance for the menfolk line. Okay, what does it say? Find the slope of the line segment for the women. To find slope, we need 2 points. You cannot find slope without a couple points. And if we look at the graph, they did give us 2 points. See, for the women way up here, we got 2008, comma, 18.3. And then we also have a point down here, 1990, comma, 14.0. So let's find the slope. The numerator is the change in the y-coordinates. This one's bigger, so I'll subtract in this direction. My numerator will be 18.3 minus 14.0. Denominator, remember to subtract in the same direction. 2008 minus 1990. If I subtract my numerator, I get 4.3. And if I subtract my denominator, I get 18. So I guess we could leave it like that. It's kind of weird to see a fraction or a decimal in the numerator of a fraction. But remember, what was our y-axis here? This is number of people living alone in the millions. So this is millions women alone. And our denominator is in years. So let's see, how do we interpret this? Well, over the span of 18 years, 4.3 million more women will choose to live on their own. Now, it's kind of weird, this number per 18 years, usually we express things as a rate per year. So what could we do here? Let me erase this a little bit. I could divide my numerator and denominator by something to get my denominator to be a 1. So it would be per year. Well, I can divide both top and bottom by 18. And then I'll get 0.24 divided by 1. And remember, this is millions per year. So that would be 0.24 million, or 240,000 more women every year live by themselves, get an apartment or a house by themselves. So that slope, it's positive slope. It is an increase. Every year, 0.24 million more women live by themselves. Again, remember, you'll be doing the same thing for the men in the practice problems. Alrighty, on to example 4. Before we get there, let's talk about an average rate of change. If the graph of a function is not a straight line, the average rate of change between 2 points is the slope of the line containing those 2 points. This line is called a secant line. Don't confuse that with secant, the trig function. For example, the figure down here below shows the graph of a particular man's height in inches as a function of his age in years. 2 points on the graph are labeled at age 13. Okay. Well, first, let's see here. As you grow, do you grow the same amount every year? Would that be a nice straight line? Every year you grow the same amount. No, you have little spurts. So here we're growing along, and then boom, we hit a little growth spurt, and we sort of rise up pretty quick. And then we level off a little bit, and it sort of slows down. And maybe in your teens, early teen years, 13, 14, boom, another growth spurt. So it gets a little steeper. And then eventually you're going to level off, and you're going to achieve your adult height. What they should show is as you grow older, your spine actually degrades and you start to shrink. As you get older, you might lose an inch or two. So this, we can't find the slope of the whole line because the slope's changing. There are steeper and less steep parts. But what we can do is find an average. So here are 2 key points. At age 13, this person was 57 inches tall. At age 18, he became 76 inches tall. So if we connect those 2 known points with a secant line, we can find the slope of that straight line, which is the average of the curve over this interval from age 13 to 18. So we take the points and we do a little computing work down here. Our change in our y is the heights, 76 minus 57, which is 19 inches. And then the change in the x coordinate on our x-axis is the years. 18 minus 13 comes out to 5. So 19 inches over 5 years. And we could just do that as a straight up division. 19 divided by 5 is 3 4/5 or 3.8. So the average from age 13 to age 18, he averaged 3.8 inches a year. Some years it was maybe a little more than 3.8. Other years a little bit less, depending on how much he grew that one year. But that's the average over our 5-year span. The average rate of change of a function. So let these be distinct points on the graph, x1, y1, x2, y2. They're distinct points on the graph. The average rate of change is subtract the y coordinates over subtract the x coordinates. That's just our formula for slope. But instead of y2 minus y1, you're seeing f of x sub 2 and f of x sub 1. Remember, that's the same thing as your y coordinate. You're just finding the slope between 2 points on a non-straight curve. Here we have a curvy curve, and we can find 2 points on it and find the secant line and get its slope, and that's our average rate of change. Let's try that here. And you're going to do something very similar in the homework. Find the average rate of change from of f of x equals x squared. That's a parabola. We're going to find the average rate of change from 0 to 1, and then again from 1 to 2, and then find the average from -2 to 0. Remember now, these are x coordinates. So I like to do it like this. F of x equals x squared. Let's say we plug in the first x coordinate, 0. 0 squared is 0. And then we plug in the other x coordinate, 1. 1 squared is 1. So there's our 2 points. Let's subtract the y coordinates. I'll go in this direction. 1 minus 0 divided by the x coordinates, 1 minus 0. So we turn out with 1 over 1, or the average rate of change is 1. And that's from 0 to 1 on the parabola. Now let's move over from 1 to 2 and see what happens. It's still, the same function, f of x equals x squared. Oop, that's a terrible exponent. That's a little better. Our first point, plug in the 1 and square it, and you get 1. And then take your other point, plug in the 2, and you square it, and the function does its work and turns out a 4. So 1, 1, and 2, 4 are our points. Let's subtract the y coordinates, 4 minus 1, over the x coordinates, 2 minus 1. So we get 3 over 1. Or, oh yeah, that's it. Yeah, 4 minus 1, 3, 2 minus 1, 1. Our slope, our average rate of change is 3. And our last little piece here, I'll switch over to red. Same function, f of x equals x squared. And what they gave us are 2 x coordinates. If I plug in the negative 2 squared is positive 4. And if I plug in the 0 and square it, I get 0. So let's find the slope. I'm going to subtract this way. 4 minus 0 divided by negative 2 minus 0. So we get 4 over negative 2, which is negative 2. And again, keep in mind, if we think about the basic graph of a parabola, it's a curve. There's our x squared parabola. To find the slope, we're finding the slope of a straight line, so that is sort of our average. Let's see what's going on here graphically. So with the first one, our first point was 0, 0, our slope, and our other point was 1, 1, and we found the slope of this secant line was equal to 1. Now, as we move along up the parabola, that secant line will get steeper. Now, this will be our left end point, and we're going to pick another point up here for the second interval, 1, 1, and 2, 4, and we find the slope between there, and it got much steeper. Slope of 3. We'd have to go up 3 and over 1, to get to the next point. Let's see, 1, 2, 3 over 1. 1, 2, 3 over 1, the slope got steeper. If we went from 2 to 3, that secant line would get even steeper. For the third one, we went to the quadrant 2. Our first point was negative 2, and we squared it and got a 4. And then 0, 0 was the origin. So we found that secant line, and that slope was negative 2. We're going downhill. Okay, what do we got here? Ooh. Sort of a real-life type example of this. When a person receives a drug injected into the muscle, you get a shot at the doctor. The concentration of the drug in your body is measured in milligrams per 100 milliliters, and is a function of the time elapsed after the injection, measured in hours. The graph shows the graph of such a function where x represents hours after the injection, and f of x is the drug's concentration at that time, x. Find the average rate of change in the drug's concentration between 3 and 7 hours. So let's see here. At time 0, the doctor takes a needle, sticks it in your arm, and the concentration, as it spreads throughout your body, gets more and more, and then your body starts to process it and whatnot and use it up. And then the concentration goes down, down, down. Eventually, you'll use it all up, and there will be no more of that injection left in your bloodstream. So we want to find the average rate of change between 3 and 7 hours. So we look at our x-axis to 3, and we go up to the graph, and we see we hit at a y value of 0.05. And then we plug in the 7, and we go up to the function, and we see we hit 0.002, or excuse me, 0.02. Those are the 2 points. We'll find the slope of the line between it. And when we look at this, we should know that it's going to be a negative answer. If we get an answer that's positive, that does not support the idea of positive slope. We are going downhill in this graph over that interval. So here's our slope equation. We find the output for f of 7, f of 3. Again, that's 0.2 and 0.05. And we subtract y minus y over x minus x, get negative 0.03 over 4. And if you divide that, you'll get negative 0.0075. So the average rate of change is that negative 0.0075. This means that the drug's concentration is decreasing at the rate of that 0.0075 milligrams per 100 milliliters every hour. And since you can't ask me a question over a video, let's see what this question is. Can you clarify how to determine the units you use when describing slope as a rate of change? Units to describe x and y tend to pile up when expressing the rate of change of y with respect to x. The unit used to express the rate of change with y with respect to x is the unit used to describe y per the unit used to describe x. So in that the figure right here, in the figure, or the y, or the drug concentration, is milligrams per 100 milliliters. And in the figure, the x-axis is described in hours. So the rate of change is described in terms of milligrams per 100 milliliters per hour. Gets kind of weird when you got two pers in there. All right, some for you to try on your own. Again, checkpoint 3, I just recopied the graph here for, we're going to do the men's slope. And then down here is just an average rate of change, so pause the video and try those, and we'll see if you got them right. Okay, let's see here. Again, to find the slope, we need 2 points. And for the men, we have 1990, comma 9. and 2008, comma, 14.7. So our slope, our rate of change, is y minus y over x minus x. And if we subtract that numerator, we get 5.7. And our denominator is 18. And you know, when I showed you in the example, we could divide the numerator and the denominator by 18, so you get a number over 1. Or you can just punch this right in your calculator. 5.7 divided by 18 is approximately 0.316667, or let's round that off to approximately 0.32. Okay, 0.32, but we don't have any units. What does that actually represent? Y-axis per x-axis. Y-axis, number of men living alone in millions. So this would be millions of men alone per year. Oops, per year. So as the years go by, every year, roughly 320,000 or 0.32 million more men live on their own. Okay, the average rate of change here. So now we got, it looks like the intervals are the same. It was 0 to 1, 1 to 2, negative 2 to 0, but now our function's different. Now it is x to the third. Oops. But the idea is the same. You know, we're just going to find an average. So the function is f of x equals x cubed. Let's think of what the graph looks like. You know, x cubed up in the first quadrant, down in the third. It's a curve, you know, so it's not going to be a straight line. We can't find the slope of the whole thing. Every point on the curve has a slightly different slope, but we can find the average. 2 points. We plug in the 0. 0 cubed is 0. Plug in the 1. 1 cubed is 1. Ooh, that looks a lot like the squared one we did. So the slope is y minus y over x minus x, or 1 over 1. Slope is 1. Let's see what happens from 1 to 2. Again, it is just the cubic function. 2 points. That is a 3. Plug in the 1 and cube it, and you get a 1. Plug in the 2 and cube it, and you get an 8. So the slope is going to be y minus y over x minus x, or 7 over 1. 7. Got pretty steep, pretty fast. Last one is negative 2 to 0. So if I plug in the negative 2 and I cube it, it's going to be negative 8. And if I plug in the 0 and cube it, I get a 0. So our slope is negative 8 minus 0 over negative 2 minus 0. The zeros are meaningless. Negative 2 divided by negative 8 is positive 4. See, does that make sense? Do I have a graph of that? No. So unlike the parabola when we went to the negative side, our slope went to decreasing. It went downhill. Now we're going from negative 2, and negative 2 on the cubic function will be down here at negative 8. And 0, 0 is the origin. So that's why we have a pretty nice steep line, even though our left endpoint is a negative, because it's the cube function. Again, if we were doing that on the parabola, it would look more like this, going downhill. Alrighty. Some problems for your enjoyment tonight. 15, 16, 17, 18, 19, 20. Make sure you read the directions and answer the question that they're asking.